Alright, so we will be discussing the portal method. So the portal method is an approximate analysis used for analyzing building frames subjected to lateral loading. Alright, for the analysis of frames, we might wonder what frames are we going to do the analysis of the portal method. So for the longitudinal frames, we are going to choose one exterior and one interior. So I mean to say, we will only analyze two longitudinal frames, one of which is an exterior and one of which is an interior frame. And for our transverse frames, we are going to consider one exterior and one interior frame. So all in all, no matter how many frames you have for your building, you will only have to analyze four frames, a total of four frames for your portal method. For in this case, we have frame 2, which is an interior frame. This is the end product of our seismic frame loading. So this is our frame. It has dimensions. We have 8 meters. Our beams are 8-meter long. And our column for the second floor is 4 meters. And our story height, rather, or the column for the first story is equal to 5.5 meters. And this second story seismic frame loading equal to 121.64331, and this 81.89,479 are what we are going to distribute among all these members of the frames. Alright, so in portal method, we have to analyze, or we have to cut in the midspan of each of these members. So for example, we have here, this is A, and this is B, and this is C, joints. These are joints. I mean to say, for us to proceed with our portal method, we first have to cut at every midspan of our members that belong to this frame. All right. We have learned in our theory of structures that if we are going to cut along a structural member, it will expose all the forces that are acting on that member. So if we're going to cut through the midspan of all our structural members, both the beam and the column, our frame will now look like this one. Alright, so this is now how our frame would look like. So I mean to say, originally, this member is 8 meters. Okay, so since we have cut through the midspan, um, this is L over 2. No, this length is L over 2. That means it's 4. And also on the other side, this is equal to 4, as well as on the other side. Okay, and also other members. And now, this column height is originally 4 meters, meaning to say if we are going to cut through the midspan, um, each of these half members will be of length 2 meters. Okay, and on the first floor, the initial height was 5.5, meaning to say half of that is going to be 2.75. Okay, so this is our working frame now. But before that, let us first discuss the assumptions for the portal method. So portal method is based on the assumption that for each story frame, the interior columns will take twice as much shear force as the exterior columns. So for example, if you are going to isolate the second floor only, meaning to say we are going to neglect this shear, na? So if you're going to isolate this upper part, and exposing its joints. So now, since we have here a shear, each of these members will also counteract or will also have to counteract this shear. Like that. Okay? So originally, kanilang gid sila. But then if you cut through the midspan, ilabay gyapon nimo na siya dinhi sa pikas. No? Counteract lang. And then, ana dito sa assumption, sa portal method, ang shear kuno nga i-resist sa interior column of the frame will be twice the shear that is going to be resisted by the exterior column. So meaning to say, if V stands for shear, the exterior columns will resist V and our interior column will now resist 2V. Alright, so for us to determine the value of each of these, which is our first step for the portal method, we are going to sum up forces along X in this whole section. So summation of forces along X going to the right is positive. So this is at the second floor. Sorry. So going to the right, we have 121.64. Let's just use 2 decimal places. And what are the forces that are acting to the left? We have V plus 2V plus V, meaning to say V is equal to 121.64 divided by 4. We have 1 plus 2 plus 1. Okay, so meaning to say our V now is 30.42, meaning to say the shear in the exterior columns will be equal to rather 3.41. Okay, and the interior column will take as twice as the exterior column. Right, so that is how it goes for the second floor part. Now, if we are so mo to siya giniha sa second floor, so now let us proceed to the first floor. So same concepts, same assumptions will be applied. So if we have shear, but this time we already have 2 shears that will be resisted by these columns. We have this one and that one. So katong ganiha, itong dili ta nag-cut sa second floor, kanilang to ang iyahang consider. So, same assumption, no? Na yung mga shear dana, and then still, the shear force that will be carried by our interior column will be twice, no? Sa gina-carry sa exterior column. So, for us to get the value of our shear, we will sum up forces along X. Going to the right is positive. So let's just equate forces acting to the right equal to the forces that are acting towards the left. So we have 121.64 plus 81.89 is equal to, we have 1, 2, 3, and 4V. Therefore, our V is equal to 50.88. And that is the value of our shear for our columns in the first floor. So now we have, that is the first step for the computation of the loads in each of the members of our frames. So if we're going to combine kani ug sa katong gibuhat ato ganiha, no, same thing, pero katong diri lang sa first floor, and then if we're going to combine that sa katong pag divide nato sa ato ang structural members in our frame, no, that's one. So mo ni siya, no, we will start from here. So kani sila muna itong mga nakuha kaganiha. 30.41, 60.82, and 30.41. They are directed towards the left, no, to counteract these force. Pero since these are the same joints, no, kani sila gibulag lang nato for convenient viewing. So kung naay padulong sa left, napoy padulong sa right, and that will be of equal magnitude. The same thing with our first floor. So now our goal in here is to be able to solve all these forces that are represented by each of these arrows, no, both the orange and the blue arrows. So what are the things that we will be doing, or the processes that we are going to adapt for us to be able to do that? Now determine the forces that are acting on each of these members now, and these forces are represented by these arrows. So the methods that we are going to use, no, um, are just those equations for equilibrium. It's either mag-summation tag moment, it's either mag-summation tag forces along x, or mag-sum tag forces along y. So either of these, no, we are going to perform so that we are able to solve for each of these forces, no? So kung asa man ta mag-summation of moment, asa ta mag-summation of forces along x and y, so mag-sum tag moment, no, diri sa mga what you call this one? Cuts. No, we have kani, pwede ta diri mag-moment. We can take moment here, we can take moment here, we can take moment here, 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 here are all the cuts, no? You can take moment in all of the cuts. And for the summation of moments, we are going to sum up moments at the joints. Okay, so same as with the method of joints in our theory of structure. So we're going to sum up moment at A, or rather, we are going to sum up forces at joints A, B, C, and all other joints. Okay, so that is where we are going to sum up our forces. Alright, now, so for the first step, we are now going to start solving for the forces. So you have to start from the uppermost left part of the frame, and we are going to run from the left to right, and then we are going to run from up to down, and then left to right na sad. So that is going to be the flow of our solution. So in this part right here, we're going to start at joint A. So by the way, we have joint A, B, C, D, E, and F. Okay, so let us consider joint A first. So at joint A, so we are going to put our focus at joint A. So the forces that we are going to solve are, we have 1, 2, and 3. Okay, so I'm going to number them so that it would be easier for us to identify. So if we are going, it's either we are going to sum up moments, we are going to sum forces along x, and some forces along Y, depende sa applicable. So in this case, at joint A, it would be easier for us to sum up moments here so that these two forces will be cancelled out, and what will remain is this force. And let us name this force as force number 2. Okay, so to solve for force number 2, we are going to sum up moments here. Okay, so this is our focus now. We're going to sum up moments here. So since this is our this is the area or point where we're going to take our moment, these two forces in here, both the blue and the orange, will have 0 moment arm, meaning they will be both become 0. So if we're going to sum up moments at that point in color red, okay, so what are the forces that are going to create moment at this point? We have summation of moment at this joint is equal to 0. Counterclockwise is positive. So now we have negative 30.41 times the moment arm 2, and we also have minus our force number 2 times the moment arm equal to 4 is equal to 0. So from this equation we can solve our force number 2, and that is equal to 60.8. So now we already have one force determined. So now at joint A, we still have two remaining forces that we have to determine. We have this and that one. Okay, so since at joint A, okay, considering the joint A in here, all the forces that are acting along the x-axis are known. We have 1, 2, and 3, except the value for this one. So I mean to say, for us to get this, we just have to sum up forces along x. So for us to get our force number 3, we will call this force number 3. Okay. So our force number 3, we have to sum forces along x, which is equal to 0, going to the right is positive at joint A. Okay. So what are the forces that are acting along x-axis on our joint A? We have, okay, so we have 121.64 minus 30.41 minus our force number 3 is equal to 0. And the value for our force number 3 would be equal to 91.23. So by the way, we have assumed na that direction of these arrows are compression. So meaning to say, if we will be able to yield an answer that is negative, meaning to say our assumption for the direction of the force in that member is the opposite. Okay, so meaning to say, we are still getting positive values, meaning to say our assumption for forces 2 and 3 are correct. So that is now our force number 3. So now for our force number 4, we can just directly sum up forces along Y at joint A. Alright, so we have made a mistake in the calculation. Again, force number 2 is equal to 15.2. This is the correct value for our force number 2. So now joint A, we only have one force unknown. We have this one. So at joint A, all the vertical forces are known. except this one, meaning to say we can just sum up forces along y at joint A. To solve for our, let us name this our force 4. So for force number 4, we are going to sum up forces along y is equal to 0. Going up is positive at joint A. So now, what are the forces that are acting along the vertical axis? We have force number 2, which is equal to 15.2, and it is directed upwards, meaning to say it is positive. So 15.2, and our assumption for force number 4 is also directed upwards, meaning to say we will assume a positive sign for our force number 4, and that is equal to 0. So the value for our force number 4 that we will get from this computation is equal to negative 15.2. Okay. So finally, we were able to get a negative value, meaning to say our force number 4 is not actually directed upwards. However, it is directed downwards. Okay. Nevertheless, we need not correct the direction of the arrows. We just have to carry the negative sign, okay, so that the computation will just be the same. No? We will retain the direction of the arrow, but we have to use the negative value. So these are the forces that are acting at joint A. So what we did at joint A is what we are going to do for the rest of the joints. Now we have joints B, C, D, E, and F. Okay? Meaning to say, from joint A, we will transfer to joint B. Once again, from joint A, we will move to the right. So now we will next consider joint B. So after considering joint A previously, which we have or which enabled us to solve for forces 2, 3, and 4, we will now move to another joint, and that is going to be the joint to the right of A, that is joint B. Although you have the freedom to either go down to joint D, but it would be more systematic if we just follow the order of the letter. So in this case, we are going to focus now on joint B. So if we transfer from joint A to joint B, these forces that are common for joints A and B, we have forces 4 and 3. So if when we move from A to B, these forces will be mirrored. So in this case, this force is still 4, and this orange force directed to the right will be equal to force 3. So considering joint B, is this one, this is now going to be our focus. We have 1, 2, 3 unknowns. Okay, so we have to solve them one by one. Alright, so let us consider, or let us notice that all the forces that are acting on or along the horizontal axis at joint B are known. No, we have 1, 2, and 3 horizontal forces, and these two have known values except for this one. So maybe we can solve for this one first, and we are going to name that force number 5. Okay, so force number 5, we are going to sum up forces along x is equal to 0. Going to the right is positive. So we have force number 3, minus force number 5 minus 60.82 is equal to 0. So we have already computed for our force number 3, which is, so this is 91.2 minus force number 5, which we are looking for, minus 60.82 is equal to 0. And the value that we can get for our force number 5 will be equal to 30.4. So we only have two more unknown forces left at joint B. So now, alright, so in this part, you can either first solve for this value or you may also solve for this value first, no? Depende na lang sa kung sa'yo mong gusto. But this time, kung kani mong gusto mabalaan una, then you would have to sum up forces in this point. Kung kani pod imong gusto mabalaan una, you will sum up forces dire. Okay? Para makancel ni siya. And kanina lang din ang unknown nga mabilin. But let us just take this one first. So we are going to sum up moments at this point. And with that, I will be coloring that with color green. So this is where we are going to sum up forces for us to be able to get the value of our force number 6. So force number 6, we are going to sum up moments is equal to 0. Counterclockwise is positive. So what are the forces that will create moment at our point color green? We have force 4 with moment arm 4 meters. That is positive because it is counterclockwise. And our force number 3 is negative, and the moment arm is 2 meters. What else? We have the 5, force number 5, it is positive because it is counterclockwise. Force number 5 and its moment arm equal to 2. And the unknown force 6, and that is assumed to be counterclockwise. So we have force 6 times the moment arm equal to 4, equal to 0. So our force 4 in here is equal to, wait, let me write that one. So our equation now would become force number 4, which we have previously solved, to be 15.2 times 4 minus force number 3, which was previously solved to be 91.2 times the moment arm 2, plus our force number 5, which is 30.4 times the moment arm 2, plus our unknown force 6 times the moment arm 4. And this will yield the value of our force number 6, and that is going to give us the value of negative 15.2. Alright, so the forces are unknown except for this force right here. So this one. So all the forces that are acting along the vertical axis at joint B are known except for this one, meaning to say at joint B, we can just sum up all the forces along Y so that we can get the value for our force number 7. So for our force number 7, we are going to sum up forces along Y going to the up is positive. So let us consider all the forces that are acting along the vertical axis. We have -4 plus force number 6 plus our force number 7 is equal to 0. So force number 4 is equal to -15.2, okay, plus our force number 6, which is equal to -15.2, plus 7 force, which is what we are trying to solve. So that will give us the value for our force number 7 equal to 0. So now at joint B, all the forces that are connected to it are already known. So from joint B, we will now transfer to joint C. Alright, so correction for the value of our force number 6. Force number 6 should be positive 15.2. Alright, so recalling all the processes that we have gone through so far. First, we have focused on joint A and determined all the forces with respect to this joint. And once we have solved all the forces at joint A, we have transferred to joint B and determined all the unknown forces. And once we were able to solve for the unknown values, we will now jump to joint C. And since this member BC right here is just the same member, even if we jump from joint B to C, meaning to say our forces 5 and 6 will be carried over and will be mirrored. So meaning to say this is force number 5 and this is force number 6. Or rather, I got that interchanged. The horizontal force is actually force number 5 and the vertical force is force number 6. Okay, so now at joint C, we will have our focus. So I have shaded that one for you. So notice with respect to joint C, we only have one unknown forces, and that is this one. And if you're going to solve or give that number 8, okay, so for us to solve for force number 8, we can just sum up forces along y. Going up is positive, so I mean to say we have -6 plus 8 equal to 0. So as we have previously solved and corrected, the value for our force number 6 is equal to positive 15.2 plus our force number 8 is equal to 0. Therefore, our force number 8 will be equal to 15.2. So now all the forces or all the member forces of our second floor were now determined. Okay, so in this case, since member AD, okay, so I'm referring to this one, is just going to be the same member when we transfer from joint A now to joint D, and from joint D thereafter we will proceed to joint E, and then from joint E we will then proceed to joint F. So everything that we have done in joint A, B, and C are what we are going to do with joint D, E, and F. Okay, so the same process. So now if we're going to transfer from joint A to joint D, okay, because we are done in this level. So if we transfer from joint A to joint D, these forces, okay, these forces in member AD will just be the same. However, it will be mirrored. So in this case, this 30.41 has a counter reaction directed to the right. And this force 2 will be mirrored, meaning to say this is force number 2. Same goes with member BE. Okay, so this force 7 in here will be mirrored here. Same as true with our shear that we have previously solved. Same as true with our force number 8 will be carried over or will be mirrored to this cut right here along member CF. Meaning to say in here this is force number 7 and force number 8. And starting with that, we will now proceed with identification of all the forces that are acting with respect to joint D, E, and F respectively. So now, after being able to go through each of those joints, A, B, C, D, and E, and F, our frame will now look like this one. Okay, so notice that there are moments here. So kanya sila, these are moments. And these are computed by multiplying this force or horizontal shear of each of the column by the moment arm. And the moment arm is equal to, this is the moment arm. Okay, so these are the base of our column. This is the moment arm, and that is equal to 2.75. That is the mid height of my column in this level. So I mean to say 139.93 is just equal to this force times the moment arm, 2.75. Same goes with this to this and this to that. So this is what your end product is going to look like, minus these annotations here. So do the same process all over again for your 3 other frames, meaning to say you're going to have 4 like this one. And that would be all. Thank you so much.